Okay, so let us look at applications of conic sections. So they say it's up to you to do your research and agree or not. So they say that if this here is the sun, okay, the Earth and other planets do not revolve around it in a circular manner, but instead it revolves around it in an elliptical manner. We know that an ellipse looks more like this, and a circle looks more like that. Okay, so that's what they say. So if this here is the planet, then this is the sun, and this sun is located at the focus. Remember we said when discussed, we've got one point here and another point here. This is an ellipse, so it has two of these, 1 and 2. So if the planet is here, then the sun would be here. Then the other sun would also be here. But in this case, in the real world, we actually have one sun. So that is why it is drawn like that. Then here's the thing. The distance from here, from the focus, okay, all the way up to where the planet is, to the vertex, okay, the longest distance, this is known as the aphelion. Apheion. Then the shortest distance from the focus, from the same focus, to the other vertex, that is known as the perihelion. What else? Yeah. Then please take note that this ellipse, when cut in half, will look like this. So, like so. Okay. Then this is the focus, and so is this. So the distance from here, from the center, up to the vertex here, okay, this is known as the mean distance. So kindly write this down. Then the distance from here to here is also known as the mean distance. So now, with that being said, I'd like us to now look at some examples or try to solve some questions. So there's this question. We're being told saying that Earth has a mean distance of 93 million miles and a perihelion distance of 91.5 million miles. Okay, find an equation for Earth's orbit. We know saying that for the ellipse, the equation at the end of it all should be x squared over a squared, because they haven't mentioned. Okay, like I've been saying, if they ask you to draw the world, you would say maybe these mountains, these are trees, these are buildings. That's how you draw it. Okay, it would be in the x-axis. You wouldn't say it can make sense to draw it like these trees, mountains, and whatnot. So in a similar way, whenever you're drawing an ellipse and they haven't specified, always draw it like so, with the a, which is the longest distance, should be in the x-axis. From here to here, this is a, should be in the x-axis, and from here to here, that's b. So we would say minus y squared over what? B squared should be equal to a. So we should be equal to 1. So let's draw this. So sorry, let's find this equation. Our equation needs to look something like that. So when we draw our ellipse, we'll have this, and we've been told saying the mean distance, meaning the distance from here to here, is 93. Okay, so that is 93. Then we're being told saying that the perihelion distance is 91.5. So meaning if the focus is here, and here, the perihelion distance, which is the shortest distance from here all the way up to there, this distance is what? 91.5. So we need to find the equation. Now to find the equation, we need to have a, we need to have b as well. Okay, and to find those, we can use a squared is equals to b squared plus c squared. Okay, now what do we have? We have our c. C is the distance from the center up until the focus. Excuse me. Or rather, we can find our C. We can first find our C. With that C being found, we can now use it to find B and A. So A, so our C Okay, let's take note of this. This is the focus, this is the focus. The C is the distance from the center up until here. But we've been told what this shortest distance is, which is the perihelion. It is 91.5. We've also been told saying that the mean distance, okay? The mean distance, mean the distance from the center up until the vertex there, is what? 93 million. So the mean distance is 93 million. So to find C, we can just say 93 minus 91.5. Now, why are we saying this? It's because this distance, which is 93, is the same as the distance from here up until here. Okay, if this is A, this would be negative A. So, meaning to find this distance, which is C, we can say the entire distance minus this. Okay, so meaning it is 93 minus what? 91.5. So, when we calculate and to find our C, we'll find that this 93 minus 91.5 is just 1.5. Okay, so we have our C. C is equals to 1.5. Now, having found our C, okay, we can now try to find our A and our B, which we will then substitute in our equation, which is this one right here. So, we have our C. Then what is our A? Our A, let's say A squared is equals to B squared plus C squared. We already know what our A is. It has been given. Remember, this is the ellipse. A is the distance from here up until here. Then B is the distance from the center up until there. Okay? If it were to be tilted like so, then our A would be this distance and this distance. Then our B would be this distance and this distance. Not combined, but this would be negative B, positive A, negative A. So, with that being said, we know what our A is. Our A is 93.93, which is the same 93 million. So this is 93. Let me just write that down nicely. So this is 93 raised to the second power should be equal to B squared plus, what is C? We said C was 1.5. So this is 1.5 squared. So there's a point there. So let's solve for B. We say B squared is equals to what? 93 squared minus 1.5 squared. Then we take the square root of both sides. We cancel this out, we cancel this out. We have B is equals to, when we punch that into our calculator, we're going to have the square root of 8,646.75. This is what our B would be. Now, let's substitute into our equation. Okay, our equation is x squared over a squared plus, minus. Wait, hold on. Yeah, so I was getting things mixed up. This here is supposed to be a plus. Okay, yeah, so it has to be plus y squared over b squared should be equal to 1. Then we know what our A is, the same 93 million. So it is 93 raised to the second power plus, what is our B? Remember, this isn't your A. Your A is just this. Okay? So in a similar way, B in this case would be this whole thing, 8646.75. The square root of this. This is B. The entire thing is B here. Okay? Then we have to raise it to the second power. Excuse me, to the second power. Then we have our equation. Okay? Should be equal to 1. We're done. If you want, you can do that. It doesn't really matter. What you're going to remain with is this. But this isn't your B. Remember, your B is everything under the square root. Let's look at another example. We're being told saying that the moon orbits Earth in an elliptical path with a center of Earth at one focus as shown in the figure. The major and minor axes of the orbit have lengths of that much, which is 768,800 kilometers and 767,641 kilometers respectively. Find the greatest and least distance, the apogee and perigee. Remember what I said? Remember what we discussed? We said the distance, okay? The distance from here, rather, this here is your focus. and this is your focus as well. Then the distance from the vertex here all the way up to the focus, the longest distance is, as we discussed, is the aphelion. Now this can also be put in a different terminology, so you may, so that, I'm explaining this that you may not get confused just in case they use something different. So this aphelion, as we discussed, is also called the apogee in this case, the apogee. Then this the smallest distance here would be the perigee. Of course, I don't think you'd forget about this. Why? Because the apogee starts with A, okay, and so does aphelion. Then perigee starts with P, and so does perihelion. Okay, so they're telling us to find these distances when all that we've been given is, as you may see in the question. So yeah, remember what we discussed. This is your sun. Okay, according to what we're just from saying, this is your sun. Then this here would be this is the path the planet moves around. Then this here is the sun located at the focus. So this is the planet, okay? Then it's moving around in that elliptical manner. Then we've been told, saying that the longest distance, okay, sorry, the minor axis and the major axis are those digits there, okay? So meaning, in this case, the major axis, which is this, its total length is given by major axis. There we have 7,600 and what? 7,600 and, sorry, please, you can pronounce this. I bet you can. But yeah, that's the major axis. Then the minor axis, okay, is 767,641. Okay. Then the major, yeah, so we've been told that. Then we've been told to find the greatest and least distance. So we need to find the aphelion and perihelion, or in other words, the apogee and the perigee. So what are we supposed to do? We can find C, okay, because C is just a distance from here to here. Finding C would do a lot, okay, but how can we find C? We can find C using the same A squared is equals to B squared plus C squared, okay. So we say A squared should be equal to B squared plus C squared. Now what is our A and what is our B? Please remember that the A is starting from here to here, so meaning we can take this whole thing, this whole distance, and then divide it by 2. Then we'll have our A. Then to find our B, we can take the minor axis and divide it by 2. Then we'll have our B. So yeah, we'll have our B. So when we divide this, let's divide this by 2. What we're going to have is this, which is A. We'll have 384,400. So it's A squared should be equal to, okay, I'm running out of space. Let's do that. Let me write that down nicely. So A would be 384,400 squared should be equal to, what is our B? Our B, let's divide the minor axis, which is this, by 2. When we do, we'll have positive B and negative B. But let's just get B. So when we divide that, we're going to have 383,800 and what? 20.5. So that as well is squared. Plus what? Plus C. Then let's make C the subject of the formula. So this would be C should be equal to what? 384,400 squared minus, this goes to the other side, minus 383,820.5 squared. So when we punch everything into our calculator, we'll find out that our C is what? 21,099. So this is our C. Okay. So having found our C, let's go back to our diagram. So having found our C, what we can do is this. Okay. Actually, let me just draw a new one. Yeah, so let me just draw a new one. So we found our C, but all that they're looking for is the distance, the longest distance and the shortest distance. So with C being found, which is the distance from the center up until here, we can just say A plus C. That is our longest distance, which is the apogee. Okay, so let's add those up. Let's take A plus C. So the apogee would be equal to C plus A. So let's add C and A. In this case, what is our C? Our C is this which we found right here, which is this distance here. Then our A is this whole distance here, okay, which is what we found when we divided by 2. So when we say C plus A, we're going to have 4,000. We'll have 405,499. So our C is what we found here. Our A is this distance. What is our A? Which is just this distance right here. This is positive A, this is negative A. Then at the top, this here is positive B, this here is negative B. Then what is our perigee, or the shortest distance, which is from here until the focus? What is that distance? We can just say the entire distance here, okay, this whole distance here, minus the the apogee, okay. We can say the entire distance minus the apogee, or we can just say the mean distance, okay, minus C. Why are we saying the mean distance? Is because the distance from here to there, okay, is the same distance as from here to there. So if the mean distance is 5, for example, meaning from here to here, if this is 5, then this would also be 5. From here to here, that would also be 5. So it would be 5 minus what? Minus C. Okay, so you can just say the mean distance, which is A minus C. So say A minus C, which is, what is our A? Our A in this case is this whole distance divided by 2, which is what we found to be this. Okay, so when we say this minus C, what is our C? Our C is this. What we're going to have, kindly punch that into your calculator. You know, the more practical you become, the better. So in this case, A minus C would then become 363,300 and what? 1. So now let's shift our focus to a different conic section, and this time it's a hyperbola. Okay, so this hyperbola, as you may see, is just a section that can be created. It has two, okay, it looks more like an ellipse but inverted. By that I mean to say like so. Okay, like they cut it in half and then they made them face different directions. So how do you come up with the equation of a parabola? You know, just as we discussed, saying that if you have your let's see, this here is your shape, your conic section. Okay, we say the distance from here up until on any surface, okay, of your parabola, so your ellipse, to the other focus. This distance from here to here should be the same as, the distance from here to here plus the distance from here to here should be equal to what? 2a. We came up with the equation and we kept on solving. So using the same analogy, here are the properties or the laws of what we can use to come up with the equation of a hyperbola. Okay, so again, if you haven't mentioned, it is convenient to assume that, okay, its orientation is like this. Okay, just as it is with an ellipse. If they don't mention its orientation, you don't have to write it down like so and say that no, your A is in the y-axis. No, you always write it down like this if they haven't mentioned anything. So in a similar way, the same goes for this. So the focus in this case is located here and here. Okay, then this axis here, just as we discussed with an ellipse, we said we've got the major axis, which is the longest, and the minor axis, which is the shortest. Excuse me. which is the shortest. So in this case, with the same knowledge, this here is a vertex. This here is also a vertex. Then this axis, okay, where the focus is located, where you've got the focus here and the focus there, is known as the transverse axis. Then this axis that does not contain the focus is not known as the transverse axis, but conjugate axis. So if your ellipse, so if your parabola looked more like this, with your focus there and another one there, then this would be the transverse axis. Then this would be the conjugate axis. So if you have, say, yeah, so let's go back to our diagram. So just as it is with an ellipse, okay, just as it is with an ellipse, let me just wrap this. Yeah, so just as it is with an ellipse, we discussed saying this here is a vertex, this here is a vertex, and so is this, and so is that, okay. So we've got the vertices in the major axis and the vertices in the minor axis. In this case, in the case of a hyperbola, okay, the vertices would be this and this, okay, and these vertices would be given by let's see, these vertices would be given by v is equals to a comma 0, okay. Then the same goes for this one right here, but this time it would be negative a comma 0. Remember what we discussed again regarding the ellipse, an ellipse rather. If this here is your ellipse, okay, your A would be along the major axis and your B would be along your minor axis. In a similar way, your A in this case, okay, would be from the center up until the vertex, the vertices. That's your A. So this is positive A, this is negative A. So meaning the coordinates for this vertex would be negative a comma 0. Then starting from the center up until where the focus is, remember we discussed and we said that that's point C, okay. When we talked about an ellipse again, we said from here all the way up to here, that's C. Your A is here, your B is there. So our C in this case would be from here all the way up to here. So meaning the coordinates for this would be C comma 0. Then the coordinates for this other focus on the other side would be negative C comma 0. Yeah, so the reason why I'm busy bringing up the ellipse is because I just want us to have the idea of how these things are coming up. So if we discussed, like I've said, from here to here, or whichever part of the surface of this ellipse, plus the distance from here up until the other vertex, okay, it is equal to this entire distance, which is 2a. In a similar way, like the same ideas, the distance from one focus to the other side, okay, on the surface of the hyperbola, minus the distance from here until here should be equal to what? 2a. And then we discussed saying that I'm just from explaining, saying that a is the distance from here up until here. So meaning when they say 2a, meaning it is equal to this entire distance. So using the distance equations, so this is just some point x comma y. You know, I've just said any point on this surface. So whichever point we're going to pick, say we've chosen this, then this is just comma x comma y. Yeah, so that's just x comma y. So meaning the distance from here up until here minus the distance from here to here, it is equal to this distance, which is 2a. So then using the distance equations, you can just watch the video I created under the same ellipse. We derived the equation. So let me not do that. It's pretty much not necessary. Yeah, you can try it out. You know, you can prove it. But at the end of it all, it is just the same as an ellipse equation, but with a minus. So this would be x squared over a squared, okay, minus y squared over b squared should be equal to 1. So this time we're using a minus and not a plus. So that's for a hyperbola. With an ellipse, it's a plus. That's the only difference. So what now? In this case, when we look at our graph, okay, our transverse axis, which is where the focus is located, like so, then this here is the transverse axis, then this is a conjugate axis. This is where the focus is located, this is where the focus is located in this axis. So it's along the x-axis. That is why our a is under the the x. Then as you may see, it is not the one having a negative. So if we have our negative, say it is written as y squared over b squared minus x squared over a squared, okay, should be equal to 1. Yeah, sorry. So this here is your, so this would be a squared minus x squared over b squared if your transverse axis is in the y-axis. Say we have so say we've got this, and then you've got your focus here and your focus there, then this will become the transverse axis. Thus your a will be under what? Your y-axis, not your x. So with that being said, let's do some practice questions. Now thing is, how do we know exactly how wide it is? Remember what we discussed regarding a parabola? We said a parabola can be like so, it can be like so, it can be like so with a focus. In this case, it would be where? Somewhere here. Then with another, it can be here, another somewhere there. Okay. Now, how can we know just how wide this hyperbola is? See, whenever you have your a, okay. Okay, I think this will be explained while we get to solve these examples. So, find the vertices, foci, and asymptotes of the hyperbola given by the equation that. So our equation in this case is what? Y squared over 9. Let me write that down nicely. So we've got y squared over 9 minus x squared over 4 should be equal to 1. So let's write it down according to the standard equation, which is y squared over how can we evaluate this that we should have a square? This is going to be 3 to the second power minus x squared over 2 to the second power should be equal to 1. So we know what our a is in this case. Our a is 3 and our b would be 2. Then when we look at it, because this here, okay, is one having the positive, and that's where our a is, then when we graph this, our a, so not our a, our shapes, our parabola will be oriented like this. Okay, so this is 3 at the bottom there. So let us move, because we've been taught saying that a is equals to 3. So meaning from here we'll say 1, 2, 3, and from there 1, 2, 3. So that's negative 3 and positive 3. So when we count 3 units up, we'll arrive at some point here, and when we count 3 units down, we'll arrive at some point here. Then what about 2? That's in the x, as we may see. So we move 2 units to the right. So that's 1, 2, and 1, 2. Okay. So let's do just that. So that's 2 here and the 2 there. So that's positive 2, negative 2, then positive 3, negative 3. Then how do we graph this? Remember, just as I said about how wide the parabola is, that is dependent upon, let me just do a quick recap about the parabola. We said if this is your parabola, okay, and then you figure out saying that your focus is located at some point P or at some point 5, okay, then the distance from here up until the other surface here and the other surface here would be 2p and 2p. Okay, so if p is 5 in this case, then this would be 5 times 2, which is 10, and 5 times 2, which is 10. So it would look like that. That's how wide it's going to be. So in this case now, how wide this will be determined by this. So let's do that. Oh yeah, so I'm just solving it without explaining. So what you're supposed to do now is you're supposed to create more of it, what do you call it, more of a box, okay, connecting these dots. So if you do that, you do that, then you also do that, it goes straight down, straight down. It looks something like this, okay. So to avoid dirty work, it will just come like so. It has to touch every surface and it has to come straight. So that's straight there, straight there, straight there, straight there, okay. Then how do we now solve this? So what you're supposed to now do is draw a line, okay, starting from one corner, passing through the center, passing through to the other corner, a straight line, okay. It will be like so. Sorry, it will be like so. Then do the same, but it has to start from here. It hits this and it hits there as well. So this is going to be like that. And remember, our parabola is opening like so. Excuse me, like so, because that's where our focus is. Now, why? Because it's under the y, the positive, okay? It's under the y. Rather, our a is under the y. And why we're considering this is because this is positive and yeah, it's positive, and as we may see, it's having y at the top. So meaning that's how our parabola is opening. So how do we then draw it? This is not the focus, remember. So it is going to come like so. It is going to touch this part. It is going to hit this. Then it's also going to touch this part. Then it goes up like that. Okay. And the same goes for down there. So starting from the surface, it just touches this vertex. Then it goes up like that. So hold on. Something like that. Yeah. So these have to be faint. The paper lines have to be faint so that you don't so that the graph clearly shows, because the paper lines here which I've drawn are only there to they're only meant to help you out draw. Our interest is in the parabola, not in them. So these are asymptotes, okay. This paper line right here, this one and this one, these are asymptotes. So the equations, these lines actually have equations, okay. So what we can now do here is this. Say we've got this line. What are we supposed to do? We'll say, rather, how can we find its equation? So these equations can be found using the principle of rise over run. What do I mean by that? To find the equation of this same line, by equation of a line, what do I mean exactly? Say you've got a graph, okay? We say this graph maybe has the equation, say 3x squared plus 2, okay? Where we say this is on the x and y axis, so this is y, this is x. If you've got your x as 1, so this is 1 2 3 4 5 6 7 and so on. So if your x is 1, what is y? Your y would be 1 raised to the second power. That would be just a 1 plus 2, which is what? 5. So meaning if this is 1, then y is what? 5 somewhere here, and so on. If x is 2, what is it that we're going to have? It will be 2 times 2, which is what? 4. Then we say 3 times 4, that is 12 plus 2. So 13, 14. Then we have 14. Meaning, if x is 2, it will be 14. So that is 1. And so it will just carry on following the sequence. So in a similar way, that is what we mean by the equation of these lines. Okay. So we've got those asymptotes. So how do we find them? We say rise over run. By that, we simply mean starting from, let me use green, starting from here, from the center, move up and end at that point, the vertex. Then move to your right and end at that point, which is guided by this point right here. Okay. So that would be, when we go up until that vertex, that would be the distance of what? 3. Remember how are we finding that 3? Here. Okay. And this 2 is the distance from the center up until here, and the distance, which is 3, from the center up until the top. So this is going to be y should be equal to rise over run. Let me use a different color. Y should be equal to rise, which is 3, over run, which is 2. Okay, and then you write your x there. So yeah, using the same principles, you said, okay, if x was 1, what would be our y, and so on. Then that's when it would graph that same straight line. Yeah, so that's the case. In this case, it's just for this line right here. Okay, what about this one? It is the same principle of rise over run. What about this line here? Okay, when we rise up, what we're going to have is positive 3. Okay, over run. When we run, where are we going to? Are we going to the right or to the left? It's this line we're interested in, not this one. So it is going to be rise run. So that is 3 over negative 2. So in this case, it would be 3 over negative 2x. That's for that line. Then what about C? We've found our A, we found our B, and we've also found our what's this? What are these? Vertices. We found our vertices as well. We've also figured out what these lines are, but we need to find our C. This C, as discussed, is the focus. So there and there. So how far are they? We don't know. Okay, it can be there where I've put these circles, or they can be upper or even lower. We don't know where they are. So to find C, you're not using the equation x squared is equals to b squared plus c squared. To find C, you're going to use the equation a squared is equals to c squared minus b squared. Okay, so that would be a squared is equals to c squared minus b squared. So let's just punch in everything. Yeah, so this is the equation to use. Remember, this is for a hyperbola. This is for a squared is equals to b squared plus c squared. This is for an ellipse. Okay, then the equation has x plus for an ellipse, x squared plus y squared, then we say is equals to 1 over a squared, then over b squared. This is for an ellipse, but for a hyperbola we say it has a negative. Okay, so let us find our C. So c squared is equals to a squared. We make c the subject to the formula. This b goes to the other side and changes the sign. This would be b squared is equals to b raised to the second power. So this would be c is equals to the root of a squared plus what? B squared. So c is equals to, what is the root of a? In fact, what is a anyway? A, remember, is in this axis. Okay, it is positive. Our equation here, as we may see, is one that's being positive, and it has our y at the top there. Okay, so what we're going to have there is, what is our a? Our a is 3. So that is 3 squared, that is 9. Then we say plus, what is our b? Our b is 2. Okay, here, this right here is our b. Yeah, so that's 2 squared, which is 4. Okay, so c, when we just punch everything into our calculator, is going to be the square root of 13. Okay, which can be rewritten or can be simplified. Actually, let's not even complicate things. Let's leave it as it is. So this is our C. Okay, so let us now graph it nicely. Just a summary. Say we have this. Our A, we had to move to the right by how many units? How many units did we move to the right? We said it is 2 to the right and 2 to the left. So that's positive 2, negative 2. Then up and down, how many units? Up, that was 3 units up, then 3 units down. Then we had to draw our shape there, touching all these parts. Then we had to draw a line moving straight, hits the center, goes up. Then another one moving straight, hits the center, it goes up. Then how do we know which side to draw it from? Should it be from here, it goes like that and like that, or it should be the other way around? Okay, we've discussed, because it is positive and we've got the y at the top there. Okay, this we've got y. Where's the equation? Here we've got y at this top here. So meaning, and it's positive, okay? Meaning our shape will open upwards. So drawing it has to touch this surface, hits this, then it goes up. So it has to hit the surface, touches the vertex, it goes up like that. We found our asymptotes. We know what this is. That's the vertex. That's the vertex. So our vertices in this case would be, so the vertices one, let's call this vertex 1 and vertex 2. So this would be, what is this? This is 3, 0. Vertex 2, that would be negative 3, 0. Okay. What else? What else? What else? Yeah. The asymptotes. We said y is equals to, what's that we said? Let's see, 3 over 2. We said y is over an x. And y is equals to negative 3 over 2x. Then what else? The focus. Okay. Meaning the focus now is starting from here up until wherever it will be. So as we've discussed, rather, as we've calculated, which is C, our focus is C, is starting from the origin going up, which is the root of 13. Whatever answer you're going to find, it is there. Okay, so meaning the focus, let's call this focus 1 at the top and focus 2 at the bottom. So that's focus 1 is equals to the root of, let me write that down nicely. So focus 1 is equals to the root of 3, comma what? No, that's x. It has to be x comma y. So yeah, so I've made a mistake. This is supposed to be vice versa. It's x comma y, yeah? So it is x 0, y positive 3. Okay, let me just write that down nicely. So the asymptotes are correct. Let me just rub this out. Yeah, so this v1, okay, in this case that's x comma 1, x comma y. Then our x would be, what is our x? Our x is 0. Our y is there at the top. Okay, sorry, here, right here. Okay, this is the vertex. Then this would be the focus at some point somewhere there. So x is 0, y the focus, which is 3. Then vertex 2 would also be x comma y. Okay, pardon my handwriting. Let me just zoom in a little bit. Then vertex 2 would be x, which is 0, comma y, which is negative 3. Okay, then the focus, okay, let's call it one at the top f1 and the one at the bottom f2. So f2 and f1. So as well, there would also be x comma y. So our x in this case would be 0 because we're in the x-axis here, 0. Then our y would be up and down. Okay, they're up and down. So it would be the root of 13 positive and 0 comma the root of negative the root of 13. So we found everything, the focus, we've graphed it, we've pretty much done everything. So let's just do another example, just so that these things should stick. So we're being told, okay, saying find the equation find the equation of the hyperbola with vertices 4, 0, positive and negative 4, 0, and foci at that point. Okay, so we've been given those things. So this here is xy axis. Okay, the vertices at x, yeah, there we have it, vertices. So remember, the vertices are these points. Okay, so if your hyperbola comes like this is a vertex, this is a vertex. If your hyperbola comes like that, okay, this is your vertex, this is your vertex. And in that same vertex, that is where the focus would be. So your focus would be in here, this same axis. That's what I mean. So yeah, so that's that. And yeah, so the vertices, as we may see, are in the x-axis because they've stored us saying that it is plus minus 4, what, 0. Okay, this is x, this is y. So it is in the x-axis that we're having the vertices. So starting from the origin and moving to the right, positive by 4, okay, that would be 4. And to the negative, that would be negative 4. So meaning the vertices are here, meaning it's opening something like this. But let me not start drawing it because we don't know how wide it is. It can be like so. It can be like that, it can be like that, who knows? Yeah. So far we've done that. Then we've been told saying in the foci is what is located is plus minus 2 root of 5 comma 0. Okay, so that would be somewhere here. Hold on, no, yeah, that would be somewhere here. That's the focus. In another one here. Okay, of course, just take the root of 5 and multiply it by 2. You see that it is greater than 4. So yeah, it is somewhere here. And even if you don't even if you don't even find it using a calculator, I think it's common knowledge, because the focus always has to be inside. Focus has to be inside, so it is expected to be greater than 4. So we know what our A is, okay, which is the distance from here to here. We know what our C is, which is the distance from here until here. Now let us find our B, because this B, when we find, we'll say from here all the way up there, positive B and negative B. Then we'll draw our square, then we'll do the needful and carry on with everything else. So our B, as we said, is not found using the equation. So our B, as we've discussed, is not found using the equation A squared is equals to B squared plus C squared. You end up being wrong. Okay, so that's what our B. So our B in this case would be, as we discussed, we're not using A squared is equals to B squared plus C squared, but rather A squared is equals to C squared minus excuse me, B squared. So A squared is equals to C squared minus B squared. So having done this, we can now what are we looking for? We're looking for B. So let's solve for B. Let's make B the subject of the formula. So that would be B squared is equals to A squared. So that would be B squared is equals to A squared minus C squared. Yeah. Yeah, so let's solve for B, since that's what we're looking for. So this would be B squared should be equal to, yeah, so this would be B squared. Yeah, so let's solve for B, since that's what we're looking for. So this would be B squared should be equal to A squared minus C squared. So that would be negative B actually. Then, if we multiply the negative both sides, this would be, let's see, C squared minus A squared. Square both sides, we cancel that out, So B should be equal to, what is our C? As we may see, our C is greater than A, which is, what is our C? Our C is 2 times the root of 5, then squaring it. So that is 2 times the root of 5, then we square it, then minus, we say A squared, which is 4 squared. Okay, when you solve for everything, we'll find that our B, okay, when we plug everything into our calculator, our B is actually what? 4. Rather, the root of 4. Okay, that is what our B is, the root of 4. Yeah, okay. Yeah, so that is our B. So having found our B, okay, say the root of 4 is located somewhere there and somewhere there. Okay, we can now draw the diagram nicely. So we can just faintly draw this, and then we draw our asymptotes. So from one corner to the center to the other corner. Okay, then from one corner to the center to the other corner. Then, as we may see, our A in our equation. So yeah, so as we may see, we've been told saying that the vertices are here and here. Thus, our equation will open like so, because you have to touch the vertex and the surface of the lines. So in this case, our equation will be, so our graph will look like so and like so, with the focus being here and the focus being there. Okay, so find the focus, find the equation of the parabola. So that is that. So now let us find our equation. Okay, so I've done everything, so just in case there may be anything they're looking for. So our equation in this case would be x squared over a squared minus y squared rather, over b squared should be equal to what? 1. Okay, should look something like this. So this would be x squared, excuse me, so this would be x squared over, what is our a? So our A is just the distance from the center, which is here, up until this distance there. So that would be 4. So that would be 4 squared minus, what is our B? Should I really explain why this is our A? Remember, this is in this axis, okay, in the x-axis. And how do we know this is this axis is our A? That's where the vertices in the focus are located. So that is our A. Then what is our B? Our B is just what we're from finding, which is, what is this? The root of 4. Okay. Our B in this case would be the root of 4. Should be equal to 1. So the root of 4 squared, by the way. So this cancels out, that cancels out. So our final equation would be x squared over 16 minus y squared over what? 4 should be equal to 1. So this is our final equation. So let me just do a few more. Yeah, so let me just do another example. Okay, let me leave this one up to you as an exercise, just so that you should get used to solving, because I'm trying to deal with time. So find the equation in the foci of the hyperbola with vertices that and asymptotes that. So that is your question. Kindly solve it, and whenever you found your answer, your equation should look like y squared over 4 minus x squared over 1 should be equal to 1. Then the eccentricity, okay, of a hyperbola. What about that? The same goes, okay. The eccentricity tells us about how wide it is. The eccentricity can look like this, just as it is with the ellipse, okay. Eccentricity is equals to c over a. It can be like so, it can be like that, it can be like that, it can look more like a circle, okay. The eccentricity just tells us more of how wide it is. So eccentricity is given by c over a, okay. So all you have to do in this case is grab your c and plug it in there. So your c would be from the origin up until here, then your a would be from the origin up until here, okay. Just do that and plug it in. Yeah, so let's do an example under eccentricity, then I'll be done for the sake of time. So I'll just skip one question, which I'll not do, just under application of a hyperbola. So it's just down there in the slide that I'm following. For the sake of time, maybe I may do it in the next video, but in the next video I'll be doing at shifted conic sections. So yeah, so that is so here's a question. Find the standard form of the equation of the hyperbola that has an eccentricity of 3 over 2, center at the origin, and the focus at 6, 0. Okay. So usually I like drawing the hyperbola because it makes it very easy for you to find everything they're looking for. So the focus is located at 6, 0. So that's here, that's 6, positive 6, and that's negative 6. Because I've said x, y. Okay. So that is 6, 0. So that is negative 6 here, and then that's a positive 6 there. So meaning we know saying that it's going to open like this. So we know saying that eccentricity is given by c over a, and we've been told saying that the eccentricity in this case is 3 over 2. Okay, so meaning e should be equal to 3 over what? Over 2. And what is our a? We don't know what our a is, okay, but at least we know what c is. What is c? C is the focus, or foci, since there are two. Let's remember that. So c in this case is, what is our c? That's what we're looking for. No, that is our 6 then over a. Then let's just solve for a. Okay, so a in this case would be 6 times 2, that is our 12. Then 12 divided, so we just cross multiply, so this would be 3a, then 6 times 2, 12 over 3 over 3. We cancel that out, our a would finally be 4. Okay, so we know what c is, we know what a is, we can just find our b, and when we find it, we just substitute in our equation. So again, we're not using a squared is equals to b squared plus c squared, but we are saying c squared is equals to what? A squared plus b squared. Okay, so we know what c is. What is our b, which is what we're looking for? So b in this case would be c squared minus a squared. So we take the square root of both sides, we cancel that out. Let me take everything this side. and I think I have enough space for now. So B would be, what is the square root of C? And what is C? As we found, our C is, of course, the distance from the center to the focus, which is 6 squared, right here in there. So minus, what is our A? Our A in this case is just this 4, which is what we found here. So 4 squaring it. Then B finally would be the square root of 20 when we just simplify everything. So having found this, let us now substitute in our equation. Our equation would be x squared over, in this case, okay, this would say x squared over a squared. Now why are we saying so? The x is not the one with the negative, so the y would be the one with the negative in this case. Then b squared should be equal to 1. Why? Because it's oriented like so in the x-axis, okay, so the x won't have a negative, so that's where our a lies. So yeah, so this would be x squared over, what is our a? Our a, as we found, is 6 squared, which is 6 times 6, which is 36, minus y squared, then we say the root of 20, which is just what? 20. Let me just say the root of 20, then squaring it over 1, okay? Then this will just cancel, that will just cancel, which is just what? 20. So that is our final answer. This is the equation that we've been looking for. So this can just go, this can just go, so you just have y squared over 20. So this is our equation. So thanks for watching. Of course, I didn't quite do everything, but by that I mean to say I wanted to do applications of parabola, but it's just one question, but I think I'll do it in the next video. But anyway, please don't forget to subscribe. You can just share this video to your friends and just encourage them. And please, for you to do well in this course, just it's all about practicing and understanding. Don't memorize little to nothing. Okay. What else? Yeah, so in the next video, we're going to do applications of shifted conic sections. It's pretty much everything, but just shifted. With everything we've been dealing with, they've all been centered at the origin. Okay, they've all been centered at the origin. We're talking about the circle, talk about maybe an ellipse, talk about the parabola. You know, they've all been centered at the origin. Okay, even the thing what I'm talking about right now, centered at the origin.